So this is a question, GATE 2017, question number 24, which states that a reversible Carnot engine is operated between temperatures T1 and T2, where T2 is greater than T1, with a photon gas as the working substance. The efficiency of the Carnot engine, or the efficiency of this particular engine, is, and there are four options which are given. So to proceed with this question, we need to know about how this reversible Carnot engine work and how we can calculate its efficiency. So let's go to the solution. So the efficiency of the Carnot engine between temperatures T1 and T2, which is given in the question, that T2 should be greater than T1. So this Carnot engine can be represented by this following schematic, that there is a source which is at higher temperature T2 as given in the question, and there is a working substance in between, and there is a sink which is at a lower temperature T1. So this T2 and T1 I have written as given in the question. Now what will happen is that from the source, this working substance will get some heat, and that amount is say Q1, and some work will be done, that is W, and Q2 amount of heat will be released to the sink. So this is the entire process, and this process which is happening on the working substance is shown in the left hand side, which is a typical Carnot cycle, which we can see here, that Q1 amount of heat is coming in when there is an isothermal expansion, and Q2 amount of heat will be released to the sink when there is an isothermal compression. So these are the two processes when heat is gained into the working substance and heat is lost to the sink. In between there are adiabatic compression and expansion, where B to C is the adiabatic expansion and D to A is the adiabatic compression, where no heat exchange takes place. So ultimately it's a cyclic process, and since it is a cyclic process, we know that the entropy change for a reversible cyclic process, I have written here cyclic process, is actually the reversible cyclic process, which is given in the question, that it should be a reversible Carnot engine. So for a reversible cyclic process, entropy change is 0. So ds is equal to 0, where S is the entropy. Therefore, if it is 0, then what is that entropy? So if we can see that from the source, Q1 amount of heat is coming into the working substance, then the amount of entropy corresponding to that will be nothing but Q1 by T2, because T2 is the temperature of the source. So Q1 by T2 is that entropy over here, Q1 by T2. And similarly, the entropy over here, which is lost, is Q2 by T1. And the net entropy change will be Q1 by T2 minus Q2 by T1. And that because this is lost, Q2 by T1 is lost. So that's why it is equal to 0, and hence we get Q1 by T2 is equal to Q2 by T1. This is the expression which we get when we apply that for a reversible cyclic process the entropy change is 0. Now once we have got this, the definition of the efficiency of the Carnot heat engine is eta, which is work done, this W, work done divided by the Q1, the amount of heat which is gained by the working substance and the work done by the working substance. So the work done by the working substance divided by the amount of heat gained is its efficiency, and W is nothing but, from this particular schematic we can clearly see that W is nothing but Q1 minus Q2, the amount of heat which is coming in, the amount of heat which is going out, and hence using first law of thermodynamics we get W is equal to Q1 minus Q2. And therefore we get Q1 minus Q2 by Q1, and we get 1 minus Q2 by Q1. And from here, from A, what we can say, from A we know that Q2 by Q1 is nothing but T1 by T2. Therefore eta will be equal to 1 minus T1 by T2. So in general, the efficiency of the Carnot engine is not depending on the nature of the working substance. We are not getting any terms which depends on the nature of the working substance. It's only dependent on the temperatures or the heats which is gained by the working substance and lost by the working substance. That's all. So it does not depend on the working substance. So in the question it is given to be a photon gas. So whether it is a photon gas or anything else, the efficiency will remain the same if T2 is the source temperature and T1 is the sink temperature. Therefore eta is equal to 1 minus T1 by T2, and that is the answer. So if we go to the question again, we can clearly see that So the efficiency of the heat engine is 1 minus T1 by T2, where T2 is greater than T1, that is T2 is the source and T1 is the sink. So B is the correct option. All other options are incorrect. Thank you.